All right, so moving on to 11.6, surface area and volume of spheres. So what a sphere is, the locus of all points in space that are a given distance from a single point. So if you think of, in three-dimensional space, a point just floating out there, and you take that distance, the same distance all around, and go every single point around that point. That distance is the radius of the sphere. The center of the sphere is the point that is equidistant from all other points on the sphere. And then the radius is a segment from the center to a point on the sphere. A chord is a segment whose endpoints are on the sphere. So you slice through, okay, 2 points that are not going through the center. That is a chord. And then the diameter is a chord that goes through the center of the sphere. All right, so let's start with the surface area of the sphere. So think of a baseball. When you're looking at the baseball, how these seams are made up. If you look at each side of the baseball, if you will, you'll see that there's 4 circles. And that's essentially the way the surface area formula works. You take 4 times pi r squared. So the radius of the sphere, right? We're going to have 4 of those circles that make up. So you can think of the circle. What if I sliced this directly in half, right through the center, right? And I held up that circle and I just stamped it on a piece of paper. The area of that circle, right, that biggest possible circle we can make from our sphere, you can wrap that around the outside of the sphere exactly 4 times. All right, so we take the area of that and then multiply it by 4. So let's find the surface area of this. We need just one thing. Right? Our formula is 4 pi r squared. What makes spheres super easy is we don't need a height, we don't need a slant height. All we need is the radius. So I have the radius here. 4 pi times 2 squared. We have 16 pi. And then the decimal equivalent. 50.3 inches squared. Yeah. So that's essentially how much leather it would take to go around the outside of your baseball if you did it in the same way. All right, try B on your own. This time we're given the diameter. So now I'm given the diameter. We know the radius is going to be half the diameter, or in this case 4. So the surface area is going to be 4 pi, that's 4 squared. So 16 times 4, which is going to be 64 pi. Multiply that out. And we get 201.1 inches squared. Questions on that? Everyone get that? Next, the great circle. The great circle is if a plane intersects a sphere and contains the center of the sphere, then this intersection is a great circle. So this essentially is the circumference of your sphere, right? The longest possible way around the outside of your sphere. Think of the Earth like the equator, going around the equator. So we're going to use, essentially for this, their circumference. So if we guys save some writing, hemisphere, another long definition. Half a sphere. Half a sphere. So we live in the northern hemisphere above the equator. Heard this language before. So just half of a sphere. What type of problems can we solve with these? A great circle on a sphere measures 12 pi feet. What's the surface area? So remember, for surface area, we need just the radius, not just the radius. So I'm given this. I'm going to set it's essentially the circumference. I'm going to set that equal to that there. So 12 pi equals 2 pi. And then I can solve for r. Dividing both sides by 2 pi. 12 divided by 2 is 6. And then to find that surface area, we'll just go back and plug that r in right there. Four, 6 squared. We get 144 pi. Or 452.4 square feet. We'll skip this. I'll give you a practice in a second. So, here's the formula for the volume of the sphere. 4/3 pi r cubed. So this idea of 4/3 pi r cubed, let's go ahead and see where this formula comes from. All right? I have a short video for you. If Jason, you mind getting the lights for me?
4 over 3 pi r cubed gives you the volume of the sphere. But where does the formula come from? First, we'll draw a perfect sphere and fill in its volume. Next, we'll divide the sphere into equal-sized pyramids with square bases. So let's take a look at one pyramid, and remember that its volume is equal to 1 over 3 area of the base times height. Now let's quickly show that the height of all the pyramids that make up the sphere is actually equal to the radius. So our equation becomes 1 over 3 area of the base times radius. And we will simplify this equation by replacing radius with r and area of the base with b. We will be numbering the bases, so we start with base 1, and our equation is base 1 r over 3. So in order to find the volume of the sphere, we simply have to calculate the volume of the pyramids and add them together, giving us a simple formula. So lining up the pyramids, we start from the beginning, and we have volume of the sphere is equal to base 1 r over 3 plus base 2 r over 3 plus base 3 r over 3. And we will continue this process up until the last pyramid. Now we don't know how many pyramids we have, so we just let base n r over 3 simply represent the last pyramid. So having added up the pyramids together, we have this complete simple formula to work with. So next, we will use algebra and begin by factoring out a 1 over 3, and we will also factor out the radius, giving us r over 3 times the sum of all bases. So now let's concentrate on the sum of all bases, and remember, these are the bases of the pyramids that make up the sphere. And as you can see, the bases actually form the surface area of the sphere. So the sum of all bases is equal to the surface area, which is equal to 4 pi r squared. Now, a quick explanation for why the surface area is 4 pi r squared is first we'll look at our sphere and take its largest possible circumference. With that circumference, we'll make a circle. And now the amazing fact is the surface area of the sphere is equal to exactly 4 times the area of the circle. The area of each circle is pi r squared. Combine them together, and we get 4 pi r squared. So now let's go back to our simple formula and replace the sum of all bases with 4 pi r squared. Now we combine the r's together to get r cubed, and now we simply rearrange the equation to get 4 over 3 pi r cubed. So 4 over 3 pi r cubed gives you the volume of any size sphere that exists.
Amazing. So let's find the volume of this one.
If you write anything on your computer, you need to get ground.
I write pretty much all day, every day.
All right, so let's find the volume of this sphere. Again, the nice thing about spheres, what we've been doing is we only need one thing, the radius. So our volume equals 4 over 3 pi times 4 to the third time. So easy enough. In your calculator, you can just do 4 divided by 3. And we get 268 0.1 meters to the third. Easy enough. All right. Moving forward. To make a steel ball bearing, a cylindrical slug is heated and pressed into a spherical shape with the same volume. What is the radius of the ball bearing made in the following slug? All right, so let's use our volume for a cylinder, right, where we have pi r squared times the height. We'll figure out the volume of this, and then we can set that equal to the volume formula for a sphere. So, volume of this guy, pi, 1 squared times the height. And we end up with 2 pi. And then the volume of our sphere is 4/3 pi r cubed. So I'm going to set these to equal to each other. So 2 pi equals 4/3 pi r cubed. So I'm going to first clean this up. Let's get rid of these pi's. We're dividing that out. And I'm going to multiply both sides by the reciprocal. That'll turn that to 1. So I get 3 divided by 2, or r to the third equals 1.5. And then we're going to take the cube root of both sides. Remember how to do that in our calculator. And I get a radius for the sphere as 1.145 centimeters, which is, makes sense, can be larger than the radius of the cylinder since it's squished into a ball. And then one last applied problem. 3 tennis balls are sold in a sleeve. We've seen tennis balls that come in the cylinder. What is the minimum volume of the sleeve if the tennis balls have a radius of 2 inches? So let me see if I can draw this for us. So we have there are 3 balls in there. They're all equal. So we want to find the minimum volume of this sleeve. The tennis balls have a radius of 2 inches. So if this radius is 2, I want to figure out the volume of this. So what's the height? So this is going to be 4 plus 4 plus 4. Each ball has a radius of 2, so therefore the diameter is 4. So the height is 12. The volume of the sleeve, pi times 2 squared, that's the height, or 48 pi. Inches cubed. Or 150.8 cubic inches. What if I wanted to take this a step further and figure out how much wasted space is in it? Did I do that? The wasted space, or all the space on the outside here that aren't occupied by the balls, I take this volume and I subtract out the volume of the 3 tennis balls. So let's figure out the volume of one of the tennis balls first. The volume of one tennis ball, 4/3 pi is 2 to the 3rd. This is 8. 8 times 4, so we have 32 over 3 pi. Or 33.5 cubic inches. Okay. That's what one tennis ball volume would be. And then we're going to multiply that by 3, figure out what all 3 tennis balls. And I get 100.5 cubic inches for all 3 tennis balls. And then to figure out how much that wasted space in there, take 150.8, the volume of the cylinder, and subtract it from the volume of the 3 tennis balls. We get 50.3 cubic inches of wasted space.